C1 2018. So we have that x minus 3 is a factor. If we set x minus 3 equal to 0, that gives us that x equals 3, which means that f of 3 must be 0. 3 cubed plus 3 squared plus 3 times p plus q has to equal 0. So 3p plus q equals minus 36. Then have x plus 1 is our divisor, which gives us that x is minus 1, but this time we have a remainder, so f of minus 1 is minus 32. Minus 1 cubed is minus 1, minus 1 squared is plus 1, times p plus q has to equal minus 32. So minus p plus q equals minus 32. We have 3p plus q equals minus 36, and we have minus p plus q equals minus 32. Both equations have a plus q, so if I subtract them, that will eliminate that. Be really careful here with signs. 3p, take away minus p is 3p plus p, so that's 4p. Q take away q is 0, and minus 36 take away minus 32 is minus 36 plus 32, minus 4, which gives us that p is minus 1. And we know that minus p plus q is minus 32, so 1 plus q equals minus 32. Q must be minus 33. To solve this polynomial, f of x equals x cubed plus x squared minus x minus 33 equals 0, then we have to factorise the cubic. We know that x minus 3 is a factor, and there are lots of ways to factorise this polynomial. You can do long division. I'm not going to show you that method. I'm going to show you a new method that I've just found on Twitter. We want to have x cubed, which means we have x squared times x minus 3. So that gives us x cubed minus 3x squared. We then want to have x squared, and we have minus 3x squared, which means we have to add 4x squared. Each time I'm adding on or multiplying by what we know is the factor. That gives me minus 12x when I actually only want minus x. So I need to add 11. Which gives me 11x minus 33. So when I add all of those together, I have x squared, x cubed, plus x squared minus x minus 33. So f of x equals x minus 3 upon x squared plus 4x plus 11. And that equals 0 when x minus 3 equals 0. So x equals 3. And when x squared plus 4x plus 11 equals 0. I'm going to use the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And what I can see here is I'm going to have a negative under the square root, so on this one there is no solution. If I taught you A-level maths, I taught you to do this by equating the coefficients. So if we have x cubed plus x squared minus x minus 33 and we want to factorise this, we know that x minus 3 is a factor. I know I have to have x cubed Well, that tells me inside my brackets I must have an x squared, because the x times the x squared will give me the x cubed. I know I want to have minus 33. Well, that tells me on the end I need to have plus 11, because minus 3 times plus 11 will give me minus 33. And in the middle, I have an unknown times x. We then consider a coefficient, so I'm going to consider x squared. And to get x squared, I multiply minus 3 times x squared, which gives me minus 3x squared, and I also multiply x times x. And what this gives me is that x squared equals minus 3x squared plus ax squared. So 1 has to equal minus 3 plus a, which means that a is 4. So my polynomial is x minus 3 upon x squared plus 4x plus 11, which is the same answer I got on the previous method. You can see here in the SEA mark scheme, they have used algebraic division to get the x squared plus 4x plus 11.